Now let's take a look at the mid-chapter review, problems 27 through 29. So on these problems, they're asking me to find a value of x where a is parallel to b, so my ultimate goal is going to be a is parallel to b. So I'm going to start out by trying to identify what type of angle pair this is. So if I look at these guys, they lie on opposite sides of my transversal here, and they are non-adjacent, and they are on the interior. They're between my two lines. So these are alternate interior angles. I'm just going to go ahead and abbreviate that, alternate interior angles. So for A to be parallel to B, well, by the converse of the alternate interior angles theorem, if these angles are congruent, then A would be parallel to B. So I just have to get these two angles here to be congruent. The way I can do that is I can make their measures the same. So to solve for equal measures, what I'm going to do is I'm going to set these expressions equal to each other. I'm going to set up an equation. So I can set up 63 equals 5x plus 3. Now I'm just going to go ahead and go through, solve for x, and that'll give me my x that will make these angles of equal measure. So subtract 3 from both sides, and I get 60 equals 5x. Go ahead and divide by 5, and I get that 12 is equal to x. So the value of x that will make these angles congruent is 12. It just so happens that when these angles are congruent, then A is parallel to B, so if x equals 12, then A and B will be parallel, and I can mark them that way. Now let's take a look at problem number 28. So let's first identify what type of angles these are here. So this is my transversal here. They're on opposite sides of the transversal. They're non-adjacent, meaning they don't lie right next to each other. They're non-adjacent, and they're on the exterior of my two lines A and B here. So they're alternate exterior angles. So I need to find a value of x to make A parallel to B. Well, by the converse of the alternate exterior angles theorem, if these two angles are congruent, then lines A and B will be parallel. To make them congruent, all I need to do is make their measures equal. And the way that I can do that is by setting these expressions equal to each other. That would make their angle measures equal. So I'm going to go ahead and set up the equation. 2x plus 27 equals 3x minus 27. Go ahead and simplify, add 27 to both sides. I end up with 2x plus 54 equals 3x. Subtract 2x from both sides. I'm just combining like terms. And I end up with 54 equals x. So when x is equal to 54, then my angle measures are equal, which means that my alternate exterior angles are congruent. So by the alternate exterior angles, the converse of the alternate exterior angles theorem, then A is parallel to B. A is parallel to B if x equals 54. All right, number 29. So number 29 is a little more involved. It has one extra step to it. Looking at this picture, I don't have any specific angle pairs that I know right off the bat how to handle. So what I usually do in this situation is I start writing down any information that I can get from the picture. So let's start here. I have that this angle measure is 104 degrees. So I'm going to go ahead and fill in what information I can from here. Well, if this angle is 104 degrees, this angle then forms a linear pair. So that means that this angle is going to be 76 degrees. For the same reason, since this angle and this angle form a linear pair, that means this angle is also 76 degrees. Then, because this angle and this angle are vertical angles, then I have 104 degrees here. So now I've filled in some information, and I have a couple of different options for how I can solve this problem. My first option is that this angle here and this angle here, well, they are alternate interior angles. My other option is that this angle here and this angle here, they are corresponding angles. And finally, this angle here and this angle here, they are same side interior angles. So depending on what theorem I want to work with, I have a couple of different options for how I can prove, or for how I can find a value of x where A will be parallel to B. Since we haven't really worked with corresponding angles yet, I'm going to go ahead and pick that strategy. So that means that we're looking at just these two angles here. By the converse of the corresponding angles theorem, if these angles, if my corresponding angles are congruent, then my lines A and B will be parallel. So all I need to do to get these angles to be congruent is to make their measures equal. And I can do that by setting these expressions equal to each other. So I have 76 is equal to 2x plus 2. Subtract 2 from both sides, and I get 74 equals 2x. Divide both sides by 2, and I get that 37 equals x. So when x is equal to 37, then my angle measures are congruent, my corresponding angles are congruent. So by the converse of the corresponding angles theorem, A is parallel to B. And so for when x equals 37, A is parallel to B. Again, you could have also done this using that if same-side interior angles are supplementary, then my lines would be parallel. I could also do if alternate interior angles are congruent, then my lines would be parallel as well. Those are also two valid strategies.